This is section 3.1, problem number 10. This problem states that a man with $20,000 to invest decides to diversify his investments by placing $10,000 in an account that earns 6.2% compounded continuously. Once we see that word continuously, we know we're using E as our base. And the other $10,000 in an account that earns 7.4% compounded annually. So we're using a combination of two different interest formulas. Further, we are told to use graphical approximation methods to determine how long it will take for his total investment in the two accounts to grow to $35,000. Now, if we look at the answer section below, it says we're going to type an integer or a decimal, and if it's a decimal, round to one decimal place. Let's begin by writing out the investment equations. So compounded continuously, that means we're using P times E to the RT. So we're putting $10,000, that's the P, into a continuously compounding account, so it's going to use base E. The interest rate is 6.2%, so when we express that as a decimal, it's 0.062, and times T, the number of years it's going to take. We're going to add that to another account that has $10,000 in it, but this one's going to be P times 1 plus R over M to the MT power. And 1 plus our R is 7.4%, so 0.074 over the number of compounds per year. Well, it's annually, so it's once per year. And in the exponent, we have 1 times T. And we want this to grow to $35,000. So I'm just going to do a simplifying step. I can simplify this parenthesis since the interest is 0.074 over 1, I can just write it as 0.074, and then we add it to 1, so this parenthesis will become 1.074, and our exponent is 1 times t. So we've simplified that a little bit, and it's going to equal $35,000. Now, because we have a common factor, we can factor out this 10,000. That leaves us with E to the 0.062 times t power plus 1.074 to the t power equals $35,000. And if we divide both sides of the equation by 10,000, we have a simpler equation, E to the 0.062t plus 1.074 to the t equals 3.5. And this is good for us because we're not looking at y values at 35,000, we're just looking at y values at 3.5. This becomes easier to look at, especially on a graphing calculator. So I'm going to open up my graphing calculator, and I'm going to go to the y equals button, and I'm going to put the left-hand side of my equation into y1, and I'm going to put the constant into y2. So e to the 0.062 times x, I don't have a t variable on my calculator. I'm going to hit the right arrow to get out of the exponent, hit plus 1.074, the caret to go back into the exponent, x. So this is the left-hand side of my equation, and the right-hand side is 3.5. So we want to know when the combination of these exponential functions are going to grow together to reach 3.5. So now I'm going to hit the graph button, and the graphing calculator will plot the exponential curve, and then it will plot the y equals 3.5, which is a horizontal line. And we see they intersect. So now I'm going to hit the second key and choose the trace button, because above it in blue it says calc. That gives me my calculate menu. Option 5 says intersect. That's how we find intersections of curves. I'm just hitting the right arrow key to move my cursor to the right. We see the cursor is on the bottom curve. So in the bottom of the calculator says first curve with a question mark. And I'm going to hit enter to say, yes, select this as my first curve. Then I see my crosshair jumps to the line above it. And the calculator says second curve with a question mark. I hit enter. Yes, choose that as my second curve. Now the calculator says guess. I just move the cursor a little closer to the intersection. There are no other intersections here, so you don't have to get that close. Just hit enter when you're in the vicinity. And now we see the cursor has jumped to the intersection point, and it's saying that this intersection occurs at x equals 8.379 and y equals 3.5. Our problem told us to round to the nearest tenth, so x equals 8.4 is going to be our answer. So t equals 8.4 years is how long it will take for the combination of these two accounts to grow to a value of 35,000.